So the last video got cut off in 7.2 when I was explaining this problem. We'll pick it up from there. I have how we find the LCD, taking 4p and 20p, or 4p and 10p, and we can break those down and make their list. 4 is equivalent to 2 times 2 times p. 10p is equivalent to saying 2 times 5 times p. So looking at what each list is missing, 4p's list was missing a factor of a 5, 10p's list was missing a factor of another factor of a 2. Because it had a single factor of a 2, it just needed 2 to match this list. Multiplying either of these lists out, 4p times 5 gives us 20p, 10p times the extra 2 gives us 20p as well. That's now going to be our LCD. That's the common denominator we want both of our fractions to have. And the nice thing about this method is that whatever we included in the parentheses here and here tells us exactly what we need to multiply our fractions by in order to get the LCD. So, looking at our two fractions, we had 5 over 4p plus 3 over 10p. So we have to multiply 4p times 5 to get the 20p. So we have to do the same to that fraction's numerator. And then the 10p we had to multiply by 2 to get the 20p. So again, times 2 in the denominator and in the numerator. Going ahead and converting those fractions after you multiply so that they have a common denominator gets us this. 25 over 20p plus 6 over 20p. Now we have a common denominator, 20p, so we can go ahead and add across the numerators, and can keep that common denominator of 20p. So 25 plus 6 gives us 31, and we keep that common denominator of 20p. And we do at this point want to check if anything divides out, any common factors of 31 and 20, and if that fraction will reduce, but there aren't any because 31 is a prime number, so it doesn't even break down at all. Alright, so that finishes that first example. Looking at our next example, we have y over y minus 2 plus 8 over 2 minus y. Now these we don't have a common denominator, but it looks kind of close. If you see, a problem like this, and you kind of look at the two denominators, you want to think, if they look almost similar to each other, you want to determine, are they actually opposites? Because if they're opposites, we could multiply by -1 to make them become the same thing. So opposites meaning here the y is positive, here it's negative, those are opposites. Here the 2's negative, here the 2's positive, those are opposites. So then this tells us our two denominators are going to be opposites. So if we have opposites, we could either factor out a -1 or multiply by a -1 to make them match. Okay. So I like the way that this has a positive y, so we can just change this second fraction. If we multiply it by a -1, okay, well, then it's going to become a -2 and a positive y, which is what we have here, and then the fractions will match each other. So whatever we do to that denominator, we have to do the same to the numerator. Change color here so I don't mess it up with the last problem. So now we can convert our fractions. The first fraction doesn't change at all because we didn't have to touch it. Y over y minus 2 plus, well, that becomes a -8 now. And we don't, well, it becomes a positive y and a -2. So that's the same thing as saying y minus 2. So now our denominators match. We can go ahead and combine. So we want to add across our numerators. Y plus a -8 is going to be the same thing as saying y minus 8. And then we keep our common denominator, y minus 2. So at this point is always where you'd want to check if things will divide out. You don't want to come here and start trying to divide out y's or 8 over 2 thinking that equals 4. Remember, if this doesn't factor, then you have to think of y minus 8 as its own, as its whole value. So we'd have to have another y minus 8 down below in order for it to factor out. Or we'd have to have another y minus 2 up top. We don't have those, so that right there is our answer. Y minus 8 over y minus 2. Okay. Move on to another example. So next example, we have 3 over x minus 2 plus 5 over x minus 6 over x squared minus 2x. Well, here we have 3 fractions, so we have to make all 3 fractions denominators match each other before we can combine. In order to do this, well, we have an x minus 2 denominator, a factor. We have a factor of a single x. And then this x squared minus 2x, we're not really sure what we have here until we go ahead and factor that denominator. Okay, so we are going to want to factor that x squared minus 2x. And it's just 2 terms, but both terms have an x in them. At least both have at least a single x in them. So we can factor out a GCF of an x. And then looking back, x times x would give us x squared. X times I minus 2 would give us the minus 2x. And that right there would be our new, well, would be the same denominator as it is written here, just in factored form. So now looking at all 3 of our denominators, we have x minus 2, we have a single x, and we have technically an x times x minus 2. What are each lists missing? Well, this list is missing an x minus 2, this list is missing a single x, and this list has both of them. So this right here, x times x minus 2, is going to be our LCD. This is the common denominator we want to make each fraction have. Okay. So rewriting our fractions, we have 3 over x minus 2. But what is that denominator missing is the single x factor. So we want to take that, put in parentheses, and multiply by an x, not just in the numerator, or not just in the denominator, but also in the numerator. Okay, then we have our next fraction, 5 over x. That denominator is missing the x minus 2 factor, so we have to multiply that fraction by an x minus 2 in the numerator and the denominator. And then lastly, we have minus 6 over, you want to just write it into the factored form, x parenthesis x minus 2. And well, that fraction already has the common denominator we wanted, so we don't have to touch that one. Okay. So going through here now and actually multiplying these out, we're going to get 3 times x, which is 3x, plus this 5 we'd have to distribute into that x minus 2 factor. So it becomes a plus 5x minus 10. And then we have the minus 6 on the end. All 3 of these fractions now had the LCD, so we could go ahead and combine them. I kind of already hinted to that, but we add 3x to the 5x minus 10, and then we subtract the 6, and all of this is going to be over our common denominator now. Our LCD, which is x parentheses x minus 2. Okay. So at this point, what we want to do is clean up the top, combine like terms, and then try to refactor the numerator if possible, and see if the numerator has either an x or an x minus 2 factor in it, and if so, we could divide it out. So again, our first step is going to be to combine like terms up top. So we have 3x plus 5x is going to give us 8x. Minus 10 minus 6 will give us minus 16 over our x minus 2 common denominator. Okay. So we then want to take this and factor the numerator if possible. And because the 8x term and the 16 term both are divisible by 8, we can go ahead and factor that out, that 8 out. So here we're going to factor, which if we pull out the 8, it will give us 8 times an x will give us 8x, and then 8 times a minus 2 will give us the minus 16 there. Still all over our common denominator, x parentheses x minus 2. So finally at this point we can see if we have any common factors, which clearly we do. We have an x minus 2 factor in the numerator and the denominator we can cancel out. So our final answer, all that's left in the fraction now, is going to be 8 over x. And that would be our answer. Okay. So, last example. We have m plus 4 over m squared minus 2m minus 3 minus m minus 3 over m squared minus 5m plus 6. So, problem like this, we don't have a common denominator once again, but in order to come up with a common denominator, we need to see what factors are in these two denominators. So we need to factor this expression, we need to factor this expression, to see what two parentheses factors actually make this and this up. Okay, so we can come here and go ahead and factor this. M squared minus 2m minus 3. We can try to factor that. Two numbers that multiply to get negative 3, that add to get negative 2. And we know we're going to have m and m because it has to multiply to give us m squared. The numbers here that will do it are going to be a minus 3 and a positive 1. Those multiply to get negative 3, add to get negative 2. Then we have m squared minus 5m plus 6. So two numbers that will multiply to give us 6 but add to give us negative 5. Again, going to have m and m. Those two numbers will be a negative 2 and a negative 3. Okay. So from that, we can come up with what our LCD should be, which looks like it is going to be, well, we have an m minus 3 and an m plus 1. This list is missing a factor of an m minus 2. And this bottom list has an m minus 2 and an m minus 3. It's just missing the factor of an m plus 1. So our LCD is going to be sticking those three factors together. We have an m minus 3. We had an m plus 1. And the only other factor that's missing would be an m minus 2. So that right there is going to be our LCD, our least common denominator. So that's what we're going to try to make both fractions denominators become. So let's rewrite our fraction problem. We have m plus 4 all over, we already factored this into m minus 3 times an m plus 1. But what is that missing in order to get our LCD? Well, it's missing an m minus 2 factor. So we have to multiply that by an extra m minus 2, which means up top here we also need to multiply by an extra m minus 2. And since this is two terms, the m plus 4, we also want to think of that as its own factor. Okay. And then the original problem was minus m minus 3 over this expression factored to m minus 2, m minus 3. Okay. So here, what was that one missing? Well, I already had the m minus 3 and the m minus 2. It was just missing the m plus 1 factor. So we need to multiply by m plus 1 in the numerator and the denominator. And once again, we need parentheses around that factor because there's two terms. Alright, so what this is going to end up giving us in the next step is going to be well, we have m plus 4, m minus 2. Minus is m minus 3, m plus 1. And it's going to be all over the common denominator we just created. So m minus 3, m plus 1, m minus 2. Okay, right there, that's our LCD. So at this point, and even over here at this point, it might be tempting to start trying to cancel out common factors, but you don't want to do any of that until we get to the very end. Okay? So what we have to do up top here is we have to FOIL out this expression in the numerator. We have to FOIL out this expression and then put a subtraction through it, and then combine, and then try to refactor, and then see if things drop out. So you don't want to check for common factors to divide out until the very end. Okay? So this is going to equal, foiling this out, it's going to give us an m squared minus 2m plus 4m minus 8. Okay? And then minus, this expression when we FOIL is still, or this is going to still need to be in parentheses, because we have to distribute this negative through it. So we're going to have m squared plus a single m minus 3m minus 3. Again, that needs parentheses just because of that negative, because of the subtraction. And it's all going to be over our LCD. And so just to save some time and space, I'm just going to write LCD. Okay. Well, now we can distribute the subtraction into this parenthesis, which will just change the sign of each term. So we now can write it as m squared minus 2m plus 4m minus 8. And now this m squared is going to become a minus m squared. The plus m will become a minus m. Minus 3m becomes a plus 3m, and the minus 3 becomes a plus 3. Alright, finally have everything expanded out. Now we can combine like terms to see what our numerator is going to become. So, combining like terms, we have an m squared minus an m squared. So those actually are going to cancel each other out. Then m terms, minus 2m plus 4m minus 1m plus 3m. So we're going to have negative 2 plus 4 gives us positive 2, minus 1 gives us positive 1, plus 3 gives us positive 4. So we actually end up with 4m, and then combining our two constants, negative 8 plus 3 gives us a negative 5. So minus 5 all over our LCD, which now I will write back out, m plus 3, m plus 1, m minus 2. Alright, so finally at this step, this is where we want to factor the numerator to see if we have any common factors to the top or bottom. We want to factor the top to see if we end up with an m plus 3, an m plus 1, or an m minus 2 factor. But 4m minus 5 is not even factorable. Okay, 4 and 5 don't share any common factors that we could pull out to make it have a parenthesis up top. So that actually would be done right there. There's nothing there's nothing more for us to do in this problem. Okay, but I would probably write a little note here. You don't check for common factors to divide out. Until here. To get all the way to this step right here. Okay? And in this case, there are none. But you do have to check, so you do always want to refactor that numerator if possible. Okay? So we don't do this until we get right here to this step. But there's nothing to do, so like I said, problem's done right here. And that's the last bit of 7.2 we need to worry about.